Did you know that starting August 1st, 2025, AWS will begin charging for the init phase of your Lambda function? That means if your functions are not optimized, you could see higher cost with every cold start. In this video, we will break down the Lambda function lifecycle and focus on the init phase. We will learn how to optimize init phase to reduce cost and make your Lambda function cost efficient. Hello and welcome everyone. My name is Harry and I am an AWS community builder and the creator of this channel. Before we dive in, please subscribe to my channel and hit the bell icon so you don't miss future videos where I cover AWS best practices, performance and cost optimization tips, and real-world cloud solution hands-on projects. Now, without wasting more time, let's get started. So just to make sure that this video helps people who are learning about AWS Lambda first time, here is a quick overview of what is AWS Lambda. AWS Lambda is a serverless event-driven compute service from AWS. It lets you run your code without provisioning or managing servers. You simply upload your code and Lambda automatically takes care of running it in response to events such as API requests, file uploads, database changes, or scheduled jobs. Now let's see some of the key benefits of AWS Lambda function. No server management. It means that you don't really have to provision, patch, or manage underlying servers. It will be taken care by AWS. Automatic scaling. AWS scale your application automatically by running code in response to each trigger. It's the cost-effective solution. You only pay for the compute time used, no charge when your function is idle. It provides built-in fault tolerance, provides high availability across multiple availability zones. It is easy to integrate with other AWS services. It can seamlessly integrate with services like S3, DynamoDB, API Gateway, Kinesis, EventBridge, and many others. It provides flexible language support. You can use Node.js, Python, Java, Ruby, or any custom runtime environment to code your Lambda function. And even you can use it for event-driven architectures. It's ideal for microservices, real-time data processing, and automation. Now let's see some common use cases for AWS Lambda. You can build like REST APIs with API Gateway and Lambda. You can process authentication, business logic, or generate responses based on your business requirements. You can use it for real-time file processing. For example, you can use it to resize images as soon as it's uploaded to S3 bucket. You can process your video documents as they arrive. You can use for data transformation in ETL. You can use it for stream processing with Kinesis or DynamoDB streams, where you can transform data before loading that into databases or warehouses. You can use it for automation and orchestration. You can run like scheduled jobs using EventBridge and Lambda integration. You can also automate AWS resource management, like you can start and stop EC2 instances. AWS Lambda can be integrated with IoT and event processing, and it can also be integrated and can be used with GenAI based applications. Now let's try to understand Lambda execution lifecycle. The Lambda execution lifecycle consists of three distinct phases: init, invoke, and shutdown. The init phase is triggered during a cold start when Lambda creates a new execution environment for a function in response to an invocation. This is followed by invoke phase where request is processed, and finally the shutdown phase where the execution environment is terminated. During the init phase, Lambda performs a series of preparatory steps where Lambda retrieves the function code from internal S3 bucket or from Amazon Elastic Container Registry. This is for the function using the container packaging. Then it configures an environment with specified memory, runtime, and other settings that you set up inside the Lambda configuration. When Lambda environment is prepared, Lambda executes your code. And if there are no more requests coming, it shuts down that execution environment and goes into idle phase. So this is how the Lambda execution lifecycle works. Now let's see what are the Lambda billing changes happened recently. Now we are talking about AWS Lambda functions which are running on managed runtimes and functions which we upload as a zip packaging or a zip archive packaging. So this changes only happened for these particular AWS Lambda functions. If you are running your Lambda function with custom runtime or you have provisional concurrency enabled on your Lambda function, there is no change for you because init duration is already a part of build duration for those functions. The current change is only for the managed runtimes and functions with zip archive packaging. So here you can see in the screenshot, the Lambda duration is 250.06 millisecond and the build duration is 251 millisecond, which is rounded up to the nearest 1 millisecond. So this is how AWS used to build all the AWS Lambda functions which were running in the managed runtimes with zip archive packaging. You can clearly see that init duration was not part of build duration. Here the init duration is 100 milliseconds, but it is not added in the build duration. Now let's see the Lambda report after the change. Active August 1, 2025, the init phase will be built across all configuration types. As you can see that init phase duration is now included in the build duration. Now going forward, for all on-demand invocation of Lambda functions which are using managed runtimes with zip archive packaging, the init duration is a part of total build duration. In our example, the build duration is now 351 milliseconds, which was 251 milliseconds in past. And this is roughly a 40% increase in your overall Lambda cost. Now let's try to understand this in more detail. Suppose you have a function which you have configured with 512 megabyte. Your execution time, let's suppose, is 150 milliseconds, and the initialization time is 50 milliseconds, and your build time is 200 milliseconds. So this is the new scenario where build time will be 200 milliseconds, including your init time and the execution time. But let's try to understand this example where we will first calculate the cost for just the execution time. Later we will add init time to the execution time, and we will calculate the cost for the total build time, which is 200 milliseconds. Okay, and also we are doing this calculation for 10 million invocations per month. So let's understand what was the cost before the changes. So same thing again, the function memory is 512 MB, execution time is 150 milliseconds, init time is 50 milliseconds, build duration 200 milliseconds, but we will not use 200 milliseconds in this example. We will only use 150 milliseconds. So for Lambda function, the total cost is the sum of number of requests and the duration. So based on the number of requests, you will see a cost, and then based on the execution and the duration and the memory allocated to your function, you will see a separate part of a cost calculation. The sum of both is basically the total cost of your Lambda function. So for example, for the request cost, we have 10 million requests per month, and AWS charges you a flat 0.20 per 1 million request. So for request, you would be charged $2. Now let's see the duration cost. So here our execution time in past, it was just the Lambda execution time that used to build. So 150 milliseconds, which is 0.15 second, and 512 MB, which is 0.5 GB. And this gives you the total GB seconds on which you will be charged. You will multiply this with your GB second cost and the invocation total number of invocations. So that will give you the total cost for your duration, which is $12.5. So which gives you the total cost of your Lambda function is $14.50. So this is what it used to cost you before this change. Now let's try to understand and calculate the same cost after the change. So total build duration is now 200 milliseconds, which is 2 seconds. So if you multiply 2 seconds with 0.5 GB, which is your memory allocated, you will get 0.1 GB seconds. Now if you multiply 0.1 GB seconds with total number of invocation, you will get like total GB seconds for your execution of your Lambda function with total number of invocations. Now the total cost is $2 for the request, and then $16.67 for your Lambda duration. So now your total cost is $18.67. Now let's see what is the increase in cost. So the increase in cost is what is the new number minus the old number. So 18.67 minus 14.50, it's like 29% increase in your Lambda cost with this new change. Just because of init duration, which we are now adding up in the build duration, you will see 29% increase in your overall cost of AWS Lambda function. This is a significant increase, right? And it's very important that we optimize the init phase and the init duration. As I mentioned earlier, during the init phase, Lambda set up the execution environment where it download the function code and create the runtime and initialize everything. So how we can make this more efficient? Like AWS recommends 2 strategies to optimize Lambda function to lower the initialization duration. The first one is optimizing Lambda package size, and second one is optimizing the code that runs within the init phase. Now let's investigate these strategies in more details. So let's first see optimizing Lambda package size. So you can reduce the function package size, but for that, you would need to import the libraries and dependencies that are actually needed for the function to work. You should not have any dependencies or libraries inside your Lambda package which are doing nothing for your function. So you should just remove those things. A smaller package means faster downloads, which directly reduces your initialization duration. For example, you can use tools like ESBuild for JavaScript to shrink your code. You can use Lambda layers to share common libraries across multiple functions, or you can remove any unused dependencies and pick lightweight alternatives. So these are some steps that you can take to optimize your Lambda package size. Reducing package size will significantly improve your initialization durations. The second strategy is optimizing code within the init phase. Now, to understand this better, you need to investigate what happens within the init phase. For example, you could be setting up and running some configuration during the init phase. And now you make it leaner and efficient to decrease your initialization duration. For instance, you can use languages like Node.js and Python. Generally, they have faster startup times compared to compiled languages like Java or .NET, especially for like small functions. You can also avoid DNS resolution or external API calls. So in case if you are running any DNS resolution or external API calls within the init phase, you could move that to the Lambda handler. You can keep global variables and reusable resources optimized so that they don't slow down the cold start. And you can also pre-calculate or pre-process data. If your function relies on static data or lookup tables, so you can probably pre-calculate and pre-process that data and keep it there in the cache, and that way you can access it for the other Lambda initializations, and that will improve the initializations for the subsequent Lambda functions. So in short, keep your package small and make your init code run fast. You can also use Lambda snapstart. If you're running your workload for Java, .NET or Python runtimes, then enabling snapstart will help you to reduce your initialization of your Lambda function. Another option is to cache the external data. If your function fetches static data from external sources like S3 or DynamoDB, download it once during the init phase and then store it in the memory for reuse purpose. This will make sure subsequent initialization of Lambda function is faster. The next step that you can consider is to use the ARM architecture. See if your workload is compatible. You can migrate to AWS Graviton to ARM-based processors, which can offer like 20% better price performance than x86 architecture at no additional cost to you. The next option is breaking down your monolith functions. It could be possible that you have a very large big function and it is having lots of dependencies, lots of libraries that you are downloading during the initialization phase. So you can kind of break down that large function into many independent tasks and consider creating small functions. This would reduce again the dependencies and code size for each individual functions and help you to quickly initialize your functions. So yeah, these are some of the basic strategies to optimize your init phase duration and reduce your cost. So doing these things will help you to reduce init cost and improve performance. So we know that AWS is a powerful serverless service. It helps you build scalable and highly available applications without worrying about servers. But to get the best value, we must watch the cost. So from August 1st, 2025, your bill will see one more parameter in the build duration, which is the initialization duration. And to save money and improve performance, use your package size, keep your init code simple, or use features like snapstart or provisional concurrency. Always monitor your Lambda with CloudWatch and track the init duration to see where you can optimize. This will help you to keep your function fast, reliable, and cost efficient. You can use tools like X-Ray to optimize your code as well. You can instrument X-Ray within your code and see what are the part of the code that you can optimize to reduce the processing and to reduce the initialization duration of your function. You can also use CloudWatch Lambda Insights to see if you want to optimize your allocated memory. That is one more place where you can optimize it and you can save some cost on your Lambda. So yeah, these are some of the strategies that you can employ and reduce cost for your AWS Lambda functions. Thank you for watching, and I'll see you in next video. Bye.